Okay, semiconductors. What are they? Well, first we need to understand what a conductor and an insulator is. A conductor is basically any material that can conduct electricity, or in this case, the flow of electrons. That's typically what we consider as electricity, the flow of charge, right? Let's say this is the center of our atom, the nucleus. You have electrons typically existing in shells around your nucleus. So you might have one over here, one over here. You might have two over here, two over here. The thing with conductors is that they have few electrons in their outer shell, which are free to move. They have some extra electrons that can escape and move around, right? And this is typically happens in metals, which are ionic, which are metallically bonded, where you have a lattice of positive ions, right? Something like this, surrounded all by a sea of delocalized electrons. You just have these tiny electrons floating about everywhere. When it comes to insulators, what happens is that these electrons are just being used up in bonding. So you've got a covalently bonded pair over here. These electrons aren't free anymore. They've just been bonded together. And that's why their outermost band, that's what we refer to over here, even in this case, the outermost band, which is called the valence band, is completely full. Let's take a look over here. What happens here is once your electrons pop out, you have a full valence band. Same thing here, where you just have a full outer band because your two atoms are sharing pairs of electrons, covalent bonding. In semiconductors, you typically use materials that have 4 electrons in the outermost shell. And in modern machinery, we use silicon. Silicon, normally, if I draw Si, let me just use Lewis structure here. If I have an atom of silicon, it's going to be bonded to 4 other atoms of silicon. And this will go on so and so. It'll keep going on and on and on and on in a crystal of silicon. But we want to make it such that they can conduct. They have 4 electrons, so if we increase or decrease if we increase the amount of electrons we are giving them, or decrease them in certain cases, we can effectively make them conduct. That's where we use something called doping. It's basically like performance enhancing drugs. You're putting the silicon on drugs to make it able to conduct better, right? So you can either dope it with 2 materials. Typically, we use 2 materials to dope. We use phosphorus, which has 15, and we use aluminum, which has 13. And if you notice, silicon has 14, so it's just on either side, right? If we're going, if we want to, let's say, give it more electrons, which of these do you think has more electrons? Phosphorus, right? Because it has 15. 15 protons, 15 electrons. So once I dope it with phosphorus, put a crystal here, let's say, phosphorus has how many electrons in the outer shell? 5 electrons. If we put like a random particle of silicon there, we'll have a phosphorus atom over here. We'll have a tiny extra electron hanging around. Now this electron goes around and starts conducting in different places. What we've done is we've given it a little bit extra negative charge, and that's why this is now called an N-type semiconductor. Negative charge, N-type. If I put in something like aluminum over here, right? And let's say we have silicon. Okay, aluminum has 3 electrons in the outermost shell, and let's say we try to bond it, right? So we'll go 1 from here, 1 from here, they bond. 1 from here, 1 from here, they bond. 1 from here, 1 from here, they bond. But wait, this silicon has 1 electron, but the aluminum doesn't have a matching one. It's like there's a hole in here. That's what we call holes. Holes are basically the absence of electrons. And the absence of electrons creates a surplus positive charge. In this case, the electrons are the charge carriers, but it's these holes, these absences that are the carriers of positive charge. And this is why we call these p-type semiconductors. That's a brief overview of semiconductors. Semiconductors are crucial in the realm of electronics, and they can branch off onto a variety of different fields with diodes and everything, and they're really helpful even when you try to understand diodes. So just remember there's two types, p-type, n-type, and the process of adding all these extra materials to give them these super